So variation seems to be probably one of the most confusing things that you guys do. And I think it's just because you're not used to understanding what variation means. So I want to just explain, like, the more hours you work, the more money you make. That means that the hours that you work increase the amount of money you make. So the amount of money you make varies directly with the number of hours you work. Okay, I asked everyone to close their Chromebooks. I'm going to ask one more time. Thank you. So when we talk about direct variation, all that means is as one variable increases, the other variable increases. Okay, as one variable increases, the other variable increases. That's all that means. Is that my pen, my marker?
Which one?
The one that you're using? Or is that Jaden's marker? Jaden is loaning out his markers. I can't believe that. He loves those. Okay, so as one variable increases, the other increases. Like, for example, the longer you study, the better your test score is. Maybe that's not necessarily true. The farther you drive, let's talk about this one. The farther you drive, the more distance you cover, right? The longer you drive, the more distance. But what about this? What if I compare the time that I spend driving to the amount of gas in my gas tank? How many of you guys driving here? All right. So how many of you guys filled up your tank, right? So you pay $50 and you fill up your car. The longer that you drive, the more time that you drive, what happens to the gas in your car? It goes down. So that's an inverse variation. Inverse means that as one variable increases, the other variable decreases. Good job. So inverse, as one variable increases, the other variable decreases. Okay. So when you read your word problems, because this is basically all driven by word problems, and I know that you guys don't love word problems. When you read your word problems, you have to just think about what is causing the other thing to increase or decrease. And that'll tell you if it's going to be an inverse variation or if they vary directly or inversely. So let's talk about direct variation. Okay. Direct variation, we use this equation, y equals k times x. K just stands for the constant of variation. That's all K is. Much like slope. K is much like slope. Okay. So if you're given an X and a Y, you plug them in and solve for K. You always have to figure out K first. Then you write the formula with the K filled in and plug in the X or the Y again and solve. So it's kind of like setting up a system. So let's just read this first example and see what is driving, like what the X variable is. What's the independent variable? So it says the score on my test varies directly. So it's going to be a direct variation. It varies directly as the number of hours I study. If I study for 2 hours, my score is 90%. So what is driving, what is the independent variable? What's representing the X, Remember, independent means that dependent, the y variable, means the value of y depends on what x is. So what is x and what is y? X is the hours. So x represents the hours. And you guys should know from math 1, especially doing parabolas, x is always time, right? X is always time. So the y variable is your score. So I said the first thing that we have to do is find k. That is the first thing that we need to do. So we're going to find k, our constant, which is, again, much like slope. So let's see. How many hours are we going to study? 2 hours. And if we study for 2 hours, what is our score? 90%. Okay. So let's see. Y equals k times x. Well, let's just plug in the values of y and x and solve for k. So y is going to be 90 equals k times 2. So now what? How do I get k all by itself? I divide both sides by 2. Divide both sides by 2, and I find out that k, my constant of variation, is 45%. K is 45%. So that's the first part. The first thing that you have to do is find k. That's the first thing that you have to do. Okay. Now that we've found k, it says, okay, so what kind of grade am I going to earn if I study for 3 hours? So what is that? Well, what information do you have? And that represents what variable? So x equals 3. We just said k is 45%. It's asking us, what is the grade going to be? What am I going to earn? So we're trying to find y. Well, let's use this formula because it's not like using that. It's not 100%. What do we set this up as? Y equals k times x. Y equals 45 times 3. So y equals what? 135%. Y equals 135%. Is it possible to get 135% on a test? I don't know. If there's bonus questions, it sure is. I mean, yeah, if there's bonus questions, I don't know. But that's how this works. Okay. So I'm just going to write a little note off to the side on your little margin that says, first, you have to identify x, like what represents x and what represents y, and then plug them in to solve for k. That's what you're doing. You have to find k, so you're going to plug it in and solve for k. That's all you're doing every single time, whether it's direct variation or inverse variation. You're going to plug it in and find k. So here's an example of inverse variation. So y varies inversely as x. So the equation that we use for this is y equals k divided by x. So you're going to figure out what your x and your y is from your word problem, plug them in and solve for k, and then write your next step, figure out what your next given is, and write an equation and solve for y. Okay. So it says the number of books in my backpack varies inversely as the size of each book. So do you guys notice how it says here y varies inversely as x? You can actually use this whole idea to tell you which one is x and which one is y. Y comes first. Y varies, the number of books varies inversely as x. What is X? The size of each book. So X is the size of the book. Y represents the number of books. So the bigger the book, the fewer you can fit in your backpack, right? Does that make sense? If the books are only, half an inch thick, you can probably put 20 of them in there. But if they're 5 inches thick, you can't fit 20 in there. So it says if each book is 150 inches cubed, what does that 150 represent? X or Y? It represents X. It's the size of the book. 150 inches cubed. How many books are they fitting in there? So Y equals number of books, 4. So we have to find K. We have to solve for K. All right. So the inverse variation, Y equals K divided by X. That's the equation we're using. Y equals K divided by X. Well, Y, 4, equals K, we don't know what that is, divided by X, 150. How do I solve? How do I get K all by itself? Yeah, multiply both sides by 150. So I find out that K equals 600. K equals 600. So that's the first thing that you have to do. You have to find your constant of variation, K. Now we're going to figure out how many books. So it says, how many books can I buy or how many books can I carry? So we're trying to figure out what the Y value is because Y is the number of books. If each book is 100 inches squared or 100 inches cubed. If X equals 100 inches cubed. So you're going to use that direct variation equation or inverse variation, sorry, Y equals K divided by X. And you're going to plug in your numbers. So Y equals, well, K is 600 divided by X, which is 100. So how many books can you carry? 6. So you can fit 6 books. As X gets bigger, so X got smaller in that instance. Do you guys see that? X started out as 150 and it went down to 100. Does everybody see that? X started out as 150 and then it decreased, like the size of the book decreased to 100. So as X gets smaller, Y has to get larger. It went from 4 books to 6 books. Inverse variation. Okay. All right. So we're going to do a couple of just something varies directly with. So if Y varies directly with X and Y equals 10 when X equals 5, find Y when X equals 7. I know you can't see that, but it's there, I promise. So the first thing that you have to know is you're talking about varies directly. So let's just look at the equation varies directly. Y equals K times X. Can you solve for K? Like, could you just get K all by itself right now and use that idea? Colt, pick your head up so I know you're with me. We're not sleeping. Get your head off your shirt, whatever it is, put it on the floor. It's not nap time. Get K all by itself right now. How are you going to do that? Yeah, divide both sides by X. So when you have direct variation, you know that K equals Y divided by X. So just set that up. You're trying to find K. That's the first thing that you have to do every single time. Well, K equals Y divided by X. So what is K, Colt? I said, what is K? What is 10 divided by 5? Hey, look at me. Don't be disrespectful to me, okay? I just asked you a question. Are you following along? So K equals 2. So now what are you going to do? Well, you're going to use that direct variation equation, y equals K times X. And you're going to find out what y equals. You're going to solve for y when X is 7. Well, y equals K, which is 2 times 7. So when X is 7, what is y? 14. Yep. Did X get bigger? X went from 5 to 7. It's getting bigger. Because it's a direct variation, did y get bigger? Y went from 10 to 14. Yeah, it got bigger. That's what direct means. As one increases, the other increases, or as one decreases, the other decreases. They have the same growth or decay. Okay. Now let's look at this inverse variation. So it says y varies inversely with x. Y varies inversely with x. So let's go ahead and do that inverse variation and figure out what k is really fast. So if I have inverse variation, I know that y equals k divided by x. Let's just solve for k and figure that out. How am I going to do that? Yeah, multiply both sides by x. So when I have inverse variation, k equals y times x. All right. So k equals y, which is 3, times x, which is 6. So what is my constant of variation? What is k? It's 18. So now we're going to use that and plug it back into the inverse variation equation. Y equals k divided by x. And it says, what is the value of y? We're going to solve for y when x equals 9. Well, when x equals 9, y equals my constant, k, which is 18, divided by 9. So what does y equal? Y equals 2. So let's look at this. Is x getting bigger or smaller? X started out as 6, and then it ended up as 9. X is getting bigger. So that means y should be getting smaller because it varies inversely. Y started out as 3, and it ended up as 2. Inverse works opposite direction. Okay. Does that make sense? Guys, I know it's hot in here. I absolutely know it's hot in here. They put a new thermostat in. It's not working, but you guys have got to keep your eyes open. Okay. Turn your page. Turn your page. Are we good with this? Okay. So I have another direct variation and inverse variation. So when we vary directly, we said that k equals y divided by x. K equals y divided by x. So it says, hey, guess what? When y is 2 or y is 2.4 when x is 3. So what is k? Well, k equals 2.4 divided by 3. So someone grab a calculator and figure that out. 0.8. Okay. So now it says, hey, well, what is the value of y when x is 1.2? Well, remember, y equals k times x. That's direct variation. So what is the value of y when x is 1.2? Well, it's 0.8 times 1.2. So what is y? What is 0.8 times 1.2? 0.96. How are we going to set up the next one? So K equals, oh, what kind of variation is this? Yeah, so K we said is Y times X, right? Isn't that what we got when we solved for K? Okay. So K equals 5 times 2.5. So what is my constant of variation? Andres, open your eyes. You're not doing yourself any good by sitting there with your hand on your head sleeping. Get your hand off your head or stand up. What is it? 12.5. Okay. So K is 12.5. So I know that Y equals K divided by X. That's what happens when we use inverse variation. I'm trying to figure out what Y is when I take 12.5 and I divide it by 3. 4.16 and the 6 repeats. You with me, Thomas? If you guys need to stand up, then stand up. So does this seem difficult? Does it make sense what we're doing? Okay. So we're only dealing with direct and inverse variation. You guys are not doing joint variation, okay? And I didn't teach you that, and there's nothing like that on your test. Go ahead and sharpen. So we're going to look at each situation and decide if it's direct or inverse. Direct or inverse, okay? So number of oranges in a box varies as the size of each orange. And think of it as this is what it's saying. As the oranges get bigger, the number of oranges that go into the box is smaller. So one's getting bigger and the other one's getting smaller. So what is this? Inverse. Okay. The distance that I run varies as my speed and the amount of time that I run. Do you guys see how this has two variables? Do you see how this one has two variables? It's your distance is varied on your speed and the amount of time. Yeah, this is a joint. So just, and I don't think that says that on your filled in notes. So if you're filled in notes, I think it says this is joint variation. This is joint variation. Okay. You have two variables. So you guys don't have to know anything like that. So this is like a skip, 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 skip. Okay, what about this one? The number of hours that the painters spend painting varies as the number of painters. So the more painters you have, the longer or the shorter time that they spend. Yeah, the more you have, the less time they spend. That's an inverse. Do you guys need me to write more painters, less time? I don't know if that helps you. More painters, less time. Okay. What about the amount of your paycheck varies as the number of hours that you work? Direct, yeah. The more hours, more money. Okay. What about the height of a child under the age of 10 varies directly as the age of the child? Because once you get to 10, you kind of level off. That's what it's trying to say. So let's see. So if you're 4 and you're 48 inches tall, and you're 5 and you're 51 inches tall, and you're 6 and you're, what's happening? It's direct. As you get older, you get taller. But that stops, like that doesn't happen forever, right? You eventually, I think as you get older, you eventually start shrinking when you get really old. I'm not really old and I haven't shrunk. I saw you look at me. Volume of a cylinder varies directly as the radius and the height. Do you guys see how this has two variables again? This is a joint. We don't do that. Okay. That is a joint, and you don't do that. So the only thing that you really need to use is this whole idea right here. And really, I would focus on knowing how to find K every single time and then plugging it into either the direct or the inverse relationship. Plug it into the direct or the inverse. Okay. Now I only made one, like I just did a front and a back on your filled out notes. I just did a front and a back on your filled out notes. Andres, are you with me? Okay, just checking. So if you guys flip over to page 44, I'm just going to do these first 4, and then I'm going to do some of your homework problems because I think that we should. So it says determine if the equation represents direct or inverse, because remember, we're not doing joint variation. So think about your variations. We know that when we do direct variation, your equation is y equals k times x, which means that k equals y divided by x. When we do inverse variation, we have y equals k divided by x, which means that k equals y times x. Remember, k is a constant. It's a number. A constant, the word constant means that it's a number. It's not a variable. It's a number, okay? So which one of these, example 10, models direct or inverse? Does number 10, example number 10, x times y equals 40, model? Yeah, k, 40 equals x times y. So this is a representation of inverse variation. What about example number 11? Direct. Because the number k equals y divided by x. What about number 12? Yeah, number 12 is joint, has 2 variables. Volume is length divided by width, right? So we don't do that. What about number 13? So think of it as this: y equals the constant divided by x. Inverse. Remember your the number is always k, right, in the equation, because k stands for the constant of variation. All right. So I'm going to do some of your homework problems with you. So you guys don't have your homework. I'm going to ask someone to pass that out. So it's the sheets right up here. I think there are 25 questions. We're going to do a couple of them together. Yeah, go ahead, right pass. Take one, pass it back. Andres, you pass that back. Hey, I'm ready to go because I've got guys downstairs waiting for this. So I'm going to do number 2 with you. Boyle's law states that the pressure of compressed gas is inversely proportional. So this varies what, Andres? Number 2. What does it say? It varies what? Well, I just read it. If you have extras, I'll take them. Do you not have any extras? Yeah, he's got. Who doesn't have one? Okay, it varies inversely. It says inversely. I just read it. Inversely. So how do we find K? This is inverse variation. How do I find K? K equals y times x. So the pressure of a certain sample of gas is 16 kilopascals when its volume is 1,800 liters. What is the pressure in kilopascals when the volume is 900 liters? Well, y kilopascals, x volume. So K, your constant, equals Y 16 times the volume, 1800. So someone figure out what that is. 28,800. All right. So we know that K is 28,800. So what is the pressure in kilopascals, meaning what is Y when K, which is 28,800, has a volume of, your X is 900. $32 kilo. It's asking you for kilopascals, right? Do you see that? So it's 32 kilopascals. It varies inversely. Let's see. X was 1800 and Y was 16. When X drops to 900, gets smaller, Y gets bigger. Okay. I want to do a direct variation word problem. Hang on. Inverse. Does anyone see a direct variation word problem I can do really fast and then get you guys on your way, other than just the number 23? Yeah, I want a word problem, not like actual big words. Sorry. Number 23. Yeah, and this really works, you guys, just so you know. This whole cricket thing. Okay, so number 23. The number of chirps made by a cricket varies directly as the temperature. So number of chirps, Y, varies directly as the temperature. That's your X. So if it's 12 degrees, when X equals 12 degrees, the cricket chirps 30 times. Y equals 30. What's K? Well, this is direct variation. So how do we do that? How do we find K when we have direct variation? Y divided by X. So 30 divided by 12 is 2.5. So K is 2.5. All right. So it says how many times per minute, how many chirps, Y, will the cricket chirp when the temperature X is 20? Well, Y equals K times X. So Y equals 2.5 times 20. How many times is that cricket going to chirp? 50 chirps. Okay.